Hello, I'm Dawid Płudowski, and together with Antoni, Zajko, Anna, Kozak and Katarzyna, Woźnica, we want to introduce our work, Rethinking of Encoder-based warm start methods in Hyperparameter optimization, which examines the usefulness of the tabular data representation in warm start of hyperparameter optimization. As for now, two approaches to tabular meta-learning exist: handcrafted meta-features and data encoders. Data encoders are newer, and our work is focused on them. They are trained to present certain properties of the data, and these properties can be formalized in the last function of the encoder. In the well-known article about dataset-to-vec encoder, we can read about the desired property of the dataset encoder, that is, ensuring close representation for batches of observation within the same dataset while maintaining distinct representation for observation across different datasets. In our work, we verified if this similarity assumption can be leveraged in the meta-task by the extensive study of hyperparameter optimization. In our work, however, we have not tested the dataset-to-vec encoder itself, but rather one of the properties that it presents. Thus, to make the research more independent, we proposed a new dataset encoder, LILTOP, that offers a similar purpose as dataset-to-vec, yet with a different architecture. Okay, let's move to the experiment details. In our work, we use three different sources of datasets to serve as a meta-model training set, which is from the OpenML repository, a medium-size evaluation set, which is from the UCI repository, and a few-shot size evaluation set from the MetaMimic work. Now, I will present the methodology of our work. First, we prepare three meta-datasets from three distinct datasets. The preparation includes one-hot encoding, numerical feature scaling, and train test split of all datasets. Next, we train both encoders on data from OpenML. Afterwards, we generate representation of all trained datasets and a database of hyperparameter optimization history. Finally, using these assets, we evaluate obtained encoders on the hyperparameter optimization warm start. First, to ensure that both encoders fulfill the similarity assumption, we tested them on evaluation sets in the graphical and numerical way. The graphical representation was made with t-SNE. On the plots, it is easy to see that subsets of the same dataset are close to each other. Similar results were obtained with numerical evaluation. Here, the accuracy is above 0.5, which means that both encoders can tell the difference between subsets of different sources. Additionally, we can see that the value of Zajinski-Harabash index is significantly higher than 1. This indicates that these representations are far from random. Therefore, considering all, we can conclude that obtained encoders meet the similarity assumption. The second stage of the evaluation consists of the evaluation of the efficiency of the encoders in considered meta-task. To warm start Bayesian hyperparameter optimization using encoders, we perform nearest neighbor search with regards to Euclidean distance between representations. Having these datasets, we propose their best hyperparameter configuration as an initial one during the optimization process. Additionally, we compare encoders to two baselines, lack of warm start and rank-based warm start, which always selects the best configurations on average in the hyperparameter base. Such a heuristic can show the performance of the approach which is not data aware. Therefore, if encoders do not outperform it, it can indicate that information from the dataset is not extensively utilized during the warm start process. Here we present the fact that lack of any warm start may lead to results that are better compared to using encoder-based results. In the critical distance plots, we can see that using encoders is statistically undifferentiated from random search, which is confirmed by ADTM plots below. Having these results, we can see that encoder-based approaches do not outperform simple heuristic. Such a behavior, taking into account meeting the similarity assumption, can indicate that such a requirement is not sufficient to produce encoders that can solve Bayesian hyperparameter optimization warm start. To summarize, in our work we showed that obtained encoders are able to capture internal structure of datasets, yet they are not able to provide gains in the Bayesian HPO warm start meta-task. and therefore there is a need for further research on representation learning design for specific meta task. That's all from me. Thank you for your attention.